Alright, this video will be about geometry buffers. This is usually one of the first things we can find out about models in a file right after we made a quick look what's inside. I'll be using again the same example of Twisted Metal game. As you remember, last time we opened the file and we can say that there are some offsets in the beginning, there are some floating points, there are some data in the end, some textures in the middle, and there are a lot of geometry everywhere across the whole file. What do we do next? As I said already, the most usual way is to start from geometry buffers because it's easier to detect, especially face buffer, like this one, and vertex buffer or buffers. In the basics video, I've discussed how to detect if what we see is a face buffer or a texture or vertex buffer, but we don't know where exactly it starts. It can be from here, probably until here, or maybe not. Vertex buffer may contain coordinates only, and here starts probably here, because here we can see 1, 1, 1 and 81, 81. Probably this is, but maybe it's different. Maybe this buffer is, this vertex buffer is for this face buffer, or maybe not. Maybe this one is for this next one, and maybe the face buffer for these vertices is in another file at all, or maybe coordinates are here and UVs and weights are in another file, just like in this game actually. Or there may be a couple of vertex buffers, one after another, same for face buffers, and so on. So we need a way to start solving this puzzle somehow. Let's discuss a few common things you can start from. For both face and vertex buffers, we can probably guess a number of elements in each, a starting offset, an ending offset, which will give us the size of it. And for vertex buffer, we can guess a stride, or like a size in bytes, which takes one vertex in a buffer. Let's start from face buffers. Looking at this one, we can probably guess that the starting offset is this 10, 22, 80. Then if we select it, until here, we have this size as FF0. Then we can search inside of this file for the offset of a buffer or for the number of elements. And actually, it can be not always count of elements. This FF0 is size in bytes. The game can have this number somewhere, which will describe this buffer, or it can have a number of elements, like indices, and since each index is 2 bytes, it will be this number. Or it can have a number of triangles in the buffer. So if we divide it by 3 again, this number can also present somewhere in the file to describe this buffer. And actually, there are such cases where you can not find any of this. Like if there is no count, it means then probably this buffer is not one buffer. Maybe it's 2 or 3 agents together. And in this case, there will be only individual counts for each part. And there will be no such number and no this number or that one. Same for offset. There can be an offset for this buffer like 10, 32, 70. It can be a little wrong, so not in this case, but sometimes, let's say it will start from here and the offset will be 4 bytes bigger. And there are cases where this offset will be found nowhere in the file, which means there are some special flags, probably. Offset can be calculated, or there is no offset at all, which means the game just reads this file sequentially, like it tells read 100 face indices, okay. Right after that, read 100 vertices, and so on. There will be no offsets in this case, okay? So what else can we tell about buffers? A face buffer will have indices for all vertices in the mesh. So in simple case, when it starts from small numbers and numbers just get bigger and bigger till the end, we can probably easily guess that maximum vertex number is 1D1 or somewhere near that. This can also be useful to start solving a puzzle. But it's not always like that. Actually, indices in a buffer can be like in random order. They can start from big numbers, then something in the middle, and the smallest ones will be in the end. So to calculate a maximum number, you can use some existing tool like hex2obj, or you can write your own little test and read all the indices and detect which was the maximum one. So what about vertex buffers? What can we tell about them? Of course, same things that I did for face buffer, like an offset, like let's guess, I already used this one. So this would be probably an offset of this vertex buffer. Then again, we can measure the buffer and guess based on its size, AEC. We don't know how many vertices it holds. In this case, there are ints, so if there are just coordinates, this will be 6 bytes for each vertex. Divide by 6, and that can be a number of vertices. And a little check, if you multiply it back by 6, you will get the same number, and which means this buffer is divisible by 6, which is a good sign, and probably we can be right. In case of floats, we will divide by C, and so on. Now let's look at a different buffer, like this one. This one probably holds a few different elements, like probably UVs, colors, maybe coordinates too. What can we tell about this one? So if you just look at the pattern of it, you can notice this repeating different numbers, like FFFF repeats every 20 bytes, like 14 in hex, and these zeros before them all the time, and then 3 something, 30 something, 30 something before that. It's actually very different for different buffers, but there are always same rule. So you can just visually detect a stride of a buffer, usually, in most of the cases. So let's scroll up until where it starts. Well, it's a big buffer. Oh, very slight change, and here it is. Okay, this is a start probably. Okay, here is probably the end. So let's try dividing it by 14. And this is a count of vertices possible. And then multiply back. No. So this is not divisible by 40. So either we made a mistake somewhere, or this buffer is not one buffer, and there are something in the middle which I missed when scrolling. So let's take, for example, this one. It's different, and it has a different stride. Well, let's look at this distinctive part. FF0, FF3, FF0, FF3. So stride for this one will be 18 bytes in hex. So let's find the possible end of this one. Well, and the texture after that. So this is a possible size. Divide by 18, multiply 18, and that's it. So this buffer is has probably 18 bytes stride and this many vertices in it. Now, if we go back to the original file ngp and search for this number, like zeros, well, we can find this number here. So it means there is probably something different. Either we don't have a number of vertices here, or we made some mistake, or there is no count at all. So we should look for the offset instead. And this brings us to the question of offsets. There are many different kinds of offsets in games. An offset can be absolute. Like this number is an actual offset inside of this file. If we go to here, we see nothing interesting. Well, anyway, absolute offset is when it's actually pointing to this file. An offset can be relative. So let's say this file has a section starting from 10,000. For example, this section would be just a section describing all the submeshes. And then offsets will be all relative to this number. So instead of, if we are searching for something here, the offset will be D0, because it's this minus this. That's a relative offset. Or sometimes, actually rarely, but sometimes it happens, there are kind of offsets relative to current position. Like there is some data, and then this is an offset, and it's just a negative number which tells us to go back 60 C bytes back from here, and this will be an offset. So this FFFF94 is an offset to here, to this 6. I know this is because I already reversed this game, which has a rare case of this kind of offsets. And if this offset would be positive integer number, it will point a few bytes ahead. Like, well, actually, all these offsets in the beginning, they are relative, not to 0 and not to the beginning of this offset table, but to each offset. Like this offset is 5238 from this point ahead. This offset is 35D228 from this point, and so on. So this is probably all that you should know about finding buffers and their properties and searching for them. Let's return to our example. Let's find some phase buffer start. Let's search for this number from the beginning of the file, and we can find it here. As I said before in other video, it's a submesh table which has a number of phases, number of vertices, and offsets to phase buffer and vertex buffer and so on. And now once you have this data, you can make a check if this is correct, start reading coordinates, phase indices, and building a test model from it. That's all. Thank you for watching.